We are now recording. Let's get the slideshow set up from the current slide. While that's coming up, let me go over a few kind of announcements just to let you know where things stand. Y'all, brace yourself for this one. I finally got all your tests graded. Well, before that, I finally got the spring schedule. I thought I had it completed, but then when I went home over the weekend, I thought of one more thing, or two maybe, that I need to change. But they're minor. They're minor. But Friday, with all the interruptions I had on Friday, I finally got it finished. Sort of. Mostly. Okay. And then, so now, over the weekend at home, I was able to get caught up some on Gary's here. Second. Oh. I got caught up on this class grading. Didn't get to the next class, but I got this class finished, and because we had a pretty busy weekend, so I just was able to do little bits and pieces here and there. So anyway, those are done. They're not on Blackboard yet, because I have this much grading to go before I can get on Blackboard, because I need to get a lot of these papers back to the students. Now, a lot of the papers I was grading for this class, this last test, I had a bunch of blank answers, okay? Meaning no answers, okay? Lexi's here. And Emmett's here. And Seth's here. All right. Anyone else come in since I called off? Okay. So, so there were a lot of blanks left. Now, I don't know if y'all are coming back to finish the test. So when I put in Blackboard, well, when I put in my grade book, I didn't put a score down if I thought pretty certain you should be coming back. A few that there was only one blank and it seemed like you had finished everything else, I went on and put a score in. But they're not on Blackboard yet. So if you could let me know if you're going to finish the test or not. Huh? Shields, got it. Kyla, right? Okay. If you will, let me know. If you are going to come back to finish the test, please do it this week. I mean, do it as soon as you can, because Wednesday I'm giving you the quiz for Module 13. So, folks, you don't want to get any further behind. Okay? So please, let's get the test finished for Module 12. Okay? Test 3. Okay. Now, I was going to wait till Wednesday to say this, but I'm pretty sure this is true. Believe it's a good news, bad news situation next week. The good news is Monday of next week, I think, is Veterans Day, isn't it? Okay? And that's a state holiday. Okay? But the bad news is that means we won't have class. Okay, so get over it. Okay. And say again? On Veterans Day? Yeah, no classes at all. Alabama is one of the few states that really celebrates Veterans Day. I mean, everybody recognizes it, but most people don't have the day off. State of Alabama does. Now, my wife works at UAB, which is also state of Alabama. They work on Veterans Day, but the two-year college system does not. So, now there is another announcement coming up. I can't remember what day it is. I think it's Thursday. We have a faculty meeting, but I think it's during my class, so it won't mess with my office hours at all. I'll check on that and let you know on Wednesday. Okay. Any questions on anything we've covered so far, where we're heading, what we're doing? Okay, just a little bit of an overview here. We're in Module 13, and we should finish Module 13, or be ready for the quiz on Module 13 on Wednesday, okay? And then the next module, I think, and then we finish Module 13 and have a test, and the next one is Module 14, which is the last module that we cover. Okay? And let me make sure on that. Yeah, module 15 is functions, and we don't cover that in this course. That's covered in Math 112. Andrew's here. All right, any questions? So we're getting, as we used to say on the farm, we're getting close to the short rows now. You know, we're at the end of the field. So, module 13. Now, I'm starting in module 13.3, the slideshow is. That's because the last things in module 13.2 were not on the PowerPoint. So I just went on and put this PowerPoint on, and let's see if we can find one with a lot of white space. That probably has the most right there. So if there are no questions, we're on module 13, page 7, the bottom half of the page. And the first one of these, this is sort of a review, hopefully. What if we had this situation? It's not a focus. It's sort of an example of a focus. To get ready for the focus, can't get my pen to set up. There we go. So it says subtract subtract 8 times the square root of 18x. Okay? That x is under the radical. Minus 2 times the square root of 32x. That x is under the radical. Okay? How would you proceed to do that subtraction? What is it we look for? You know, it's been a long weekend. Second? Yes, let's see if there are any perfect squares lingering in the radical. Do you see any in that first one? Second? 4? Perfect square of 4 is 16. Yeah. Second? 18 is not a perfect square. Is there a perfect square hiding in 18? 9 is in there, isn't it? So let's factor out the 9. So that will be 8 times the square root of 9. And what's left over? 2x. Perfect. Minus 2. Are there any perfect squares hiding in, say, 32? Any perfect squares hiding in 32? Anybody? Second? 25? Okay, now they have to be factors, not sums. Factors. 5. No, okay. 5 squared is 25. 25 is not a factor of 32. We need things that are factors of 32. Go down 1. 4. What's 4 squared? 16. Is that hiding in 32? Yes. Okay. So we'll factor out a 16. And what's left? Say again? 2x. Perfect. Well, what is the square root of 9? So this is 8 times 3 times the square root of 2x minus 2 times what square root of 16? 4 times the square root of 2x. So 8 times 3 is 24. Second, okay. Times the square root of 2x minus, and so it's 2 times 4? 8. Square root of 2x. And then what can we do? Yes, and what does that give you? Second? 16. 16 square root of 2x. Does everybody see that? Any part of that you don't understand how we did it? Okay, because I was going by what y'all were saying. Any questions? Got it? Okay. See in the book, hey, they got 16 times square root of 2x as well. Now, they also have a focus here that's not on the slide set, So let's do the focus. It's a two-part, so I'm going to erase what I've got here. Everybody got it? Okay. Wait, I'll leave it a little longer so I see people writing. Got it? Everybody? All right. So let's erase this. Where is my... There it is. Okay. Erase that. And let's go on to the focus. Bottom of page, module 13, page 7. Simplify this. 3 under the square root of 12x cubed minus 2x on the square root of 3x. Okay. What would we do with that? Second? Okay, is 6 a perfect square? No. Second? It doesn't have one. Okay, no perfect squares hiding in 12. What are your perfect squares, by the way? 0, 1. Okay, we never mess with either one of those. Next perfect square after 1. Again? 4. Is 4 hiding in 12?
Yeah, I thought you said it was not.
I thought you said 6.
Oh, I did.
Oh.
Somebody else said 3 or 4.
Oh, I didn't. I can't hear. Okay. Sorry. Okay, so this will be 3 times the square root of 4. Okay. Are there any other perfect squares hiding in there? Okay, 3 is not a perfect square. X what? X squared. X squared is a perfect square. Okay. And what's left after you take out the 4x squared? 3x. Perfect. Minus 2x. And guess what? 3x doesn't contain any perfect squares, so you leave that alone. All right. 3. Now, what's the square root of 4? 2. What's the square root of x squared? X times square root of 3x, I can't write, minus 2x times the square root of 3x. Okay? That's really ugly, isn't it? Hey, hey, hey. Did I ask for honesty? No. You're supposed to say, oh, we can read it. Nothing to worry about. Okay? All right. So 3 times 2 is? I'm sorry? 6x times the square root of 3x minus 2x times the square root of 3x. And what would that leave us with? 4x times the square root of 3x. Let's see how we did. Oh my goodness, that's what they got to. Say again? I can't hear.
She said, oh my goodness.
Oh, yes, exactly. My word, okay. All right, that's the A part of that one. There is a B part coming up, and because it's a little bit longer, I'm going to need a lot of white space, I think. So I'm going to wait till y'all got this, and then I'll erase. Okay? Any questions so far? Does any of this part look confusing? How can you do this? Why can you do this? What does that mean? Any of that kind of stuff. Everything's making perfect sense, right? Good, good. All right. Now, if you have questions, please ask. Please ask. Grading these papers, I realized there were a lot of questions that weren't asked that should have been. Okay? All right. No, still writing. Okay. All right. Everybody got it? All right, then let's erase what we got and go to the B part of the focus. Here we have a 2x onto the square root of 8y minus 3 times the square root of 2x squared y plus 2 times the square root of 32, I can't write, x squared y. All that under the radical. Okay? All right. What do we look for first? Any perfect squares. Let's write down the 2x. That's outside the radical. We don't care about that. Any perfect squares inside 8 or y. Yeah, 4 is inside 8. What does that leave us with? 2y, square root of 2y, minus 3, leave that alone, square root of any perfect squares and 2x squared y. X squared is a perfect square, pretty obviously, and what you're left with is 2y. And then we have a plus 2, and any perfect squares in that. Second? 16, there's certainly 16 in there. And an x squared. And what are you left with? 2y. That's looking pretty good, isn't it? So this is 2x. What's the square root of 4? 2 times the square root of 2y. Minus 3. And what's the square root of x squared? X times the square root of 2y. Plus 2 times. And what's the square root of 4 what? 4. Whoa, I left off the square, didn't I? Okay. 4x, right? Times the square root of 2y. Okay? What's 2x times 2? 4x times the square root of 2y minus 3x times the square root of 2y plus 8x times the square root of 2y. And what does that yield us? Let's add the positives first. That'd be 12 minus 3. Or do it any way you want to. 4 minus 3 is? So that would be 9x. 9x times the square root of 2y. Perfect. Any questions on that? Got it? Any of, why isn't this or anything else? Well, people are writing, I'm just going to give you a for instance of what I saw in the last test. It doesn't really apply too much here. I still had people canceling out things that were added and subtracted. You can only divide out things that are multiplied. And I thought we were through with that, but they were popping their heads up again and tripping people up, or whatever. So please, folks, stay on top of the stuff. And by the way, the book also had 9x times the square root of 2y. All right, everybody got it? Okay, that finishes 13.3, except for there's a check yourself 2 on the top of page 8 of module 13. It has 2 pieces to it. Please do those 2. And then there are 7 practice problems. Please do all of those. This book has precious few practice problems. Please do them all because this is about as many as I've seen in any section. So take advantage of them and get those done. Now, if you have problems with them, there are solutions on page S6 in your text, so you can go back to the end of the section and find those solutions. If you're in doubt about your own, or check your answers back there. Okay, with that done, we're now ready for section 13.3. Any questions on anything so far in module 13? Anything? Okay. Module 13.3 then is multiplication and division of radical expressions. The last module was adding and subtracting. That was pretty straightforward. Always simplify your expressions as much as possible. The main thing so far being pulling out radicals out of the radical, perfect squares or cubes or whatever happens to be in there. We haven't gone to the higher order roots yet. I don't know if this section's going to get to it or not. I think it might. So let's move to multiplication and division of radical expressions. Okay? And Pablo's here. I think I've already marked you here once by mistake. Let's see if I did. Pablo. Yes. So you are indeed here. Officially this time. Okay. Now, Objective 13.3a is multiplying radical expressions. Okay? Now, here are some of the rules that we'll be following. The product property of square roots is used to multiply variable radical expressions. If you have the square root of something times the square root of something else, the key here, these roots are the same. They're both square roots, right? Then what you can do, since this is multiplying two roots, that's the same as the root of their multiple, okay? In other words, the square root, the product of the two square roots is the square root of the products, okay? It's that simple, okay? So the square root of 2x times the square root of 3y is the square root of 2x times 3y, same sign here, times. And then when you multiply these things together, you get the square root of 6xy. Now, when you get to that final answer, you always look and see, are there any perfect squares hiding in there? No, they're not. Okay? So you're okay. Now, but when the expressor, I think that's the expression, whoever the slide person wasn't being too careful here. Whenever the expression, the square root of x squared, is simplified by using the product property, the result is x. Because this is the square root of x times the square root of x, that would be the square root of x times x, and that would be the square root of x squared, which of course is x. Okay? The result is that, just like they showed here. Square root of x, the square root of x squared is the square root of x times the square root of x, which is square root of x times x, which is square root of x squared, which is x. Okay. Now, let's step back for a moment and see what that was doing for us. If you're raising a radical to a power, you can either do it outside the radical or inside the radical. It doesn't matter. That power can go in or out. It's going to give you the same answer. Okay? So that's something that we're going to run into a little bit later, and we'll realize that is a handy little thing to know. Okay? Either one of those expressions gives you x. The square root of x squared is just x, or the square root of x squared is just x. Okay, any questions on that? Okay? Now, that leads to the statement here. Square of a square root for any a greater than 0. Remember, we always want our things inside the radical to be positive, okay, if it's even root, okay, index. So if a is greater than 0, meaning positive, okay, the square root of a squared is indeed a. Same as the square root of a squared. That's indeed a. Now, I'm not absolutely certain why they say greater than 0. They could have said greater than or equal to 0. Because if that was a 0, it's still a 0. So they could have included 0. You can't include anything other. So let's do what this is. What in the world is the square root of 3 squared? 3. What's the square root of 5y squared? 5y. Y'all are good. Okay? Or you looked at it before. I don't know. Okay. All right. So let's make sure that they... Oh, man. I wasn't paying attention to the book. Let's step back a step. We won't say that all stuff again. Well, we'll use the slide, okay? They had a couple of things right under this, but there's not room to put it there. We'll do it here. Let's multiply these. Multiply the square root of 2x squared times, and this is q, right? Okay. Right, good deal. Okay, square root of 2x squared times the square root of 32x squared. No, x to the fifth. I can't read. Yes, sorry. All right. The first one is an x squared. The second one's an x to the fifth. We're multiplying these. Now, folks, you have a couple of options here. I really don't care which way you go with it. You can go either way. You can first try to simplify each of those separately and then multiply your product. Or you can go and multiply and then try to simplify. Doesn't matter. One or the other, doesn't matter the order. I actually like to simplify everything first, and it keeps the numbers smaller. It might take a little longer, maybe, but it's not too bad. Okay? So what you want to do? Simplify, then multiply, or multiply, then simplify? Let me know. You have no opinion. It's a Monday morning. Okay, right. Come on. Simplify first. I like the idea. What can we do to simplify the first one? Okay. And how would you factor it? X squared. Yes, factor out the x squared because that's a perfect square. And we're left with the square root of 2, which is not. Then we're going to multiply that by the square root of 16. Any more? X to the fourth. Perfect. Okay. And what does that leave us with? The square root of 2x. Wow. Okay. Now, what do we have left? Square root of x squared is x times root 2. Square root of 16x fourth is 4 what? X squared. Perfect. Times the square root of 2x. And that x is under the house there. Okay. So let's multiply our things together here. X times 4x squared would be 4x cubed. And what we have left is the square root of 2 times the square root of 2x. And what does that produce? 4x cubed times, say that, square root of 4x. Is that what I heard? Yes, thank you. Okay, and that's 4x cubed. And what about that square root of 4x? Can we simplify that any? What? Yes, the square root of 4 is 2, and you're left with just the square root of x. So this would be 4x cubed times 2 times root x, which would be what? Would be what? 8x cubed times root x. Can't get rid of that root x, but everything else came out.
Well, now, wait a minute.
Yes.
You keep lost me. Okay. On the 2 times the 2x, no, down one. Right there. Okay. Why is that okay to multiply it with the x even though there's no x there?
Okay. Remember the rule. Okay, hold on just a second. Remember that rule there? The product of two radicals, as long as they have the same index, is the radical of the product. Right? Right there. Okay? The product of the radical of two radicals is the radical of their products. Right? We did that earlier. We did it here. Okay? 6x. Okay? Now, we do the same thing here. Once you get this, you can go and multiply that under the same radical. And that's what gave you the 4x. And that made then the 4 a perfect square. And then you can pull it out too. Now, here is the advantage of doing it the other way. If you had started doing that, 2 times 32 is 64, which is itself a perfect square. 8. And if you multiply these two together to begin with, that would have been x to the what? Oh, we've forgotten that, huh? What did you say? Somebody? Thought someone said it. When you add, multiply two, same base, different exponents, you beat the base, add the exponents, that'd be x to the 7. And that would be an x times x to the 6, and square root of x to the 6 is x cubed. Square root of 64 was 8, and you have the square root of x. So you could have gotten there a little quicker by doing it this way, by multiplying first. You can't always, and sometimes it just makes your numbers bigger and harder to deal with. So you decide which way you want to do it. Either way is fine. Johnson, I thought it was. Okay. Kylie. Okay, I marked you here once when you weren't here, so I'm correcting that now. Okay. Okay. Anyone else come in since I called it on? So 2 ways to do that. This was a little bit longer in this case. Other times they're going to be about equivalent. This could be a little easier at times. Don't know. I tend to want to keep the numbers as small as possible, so do as much as I can as early as possible, and then do whatever else I can, even when it's tricky. Okay? Calling into play several of the things. We're on, it's sort of a little example at the bottom of page 8 in Module 13. Just about to do the focus on multiplying radical expressions, which is also not in the slide set. So we're going to have to use this white space again. Everybody got it? Okay. I'm going to erase all that scratch. Okay. And let's do the focus. And it says to multiply this. The square root of 3x to the 4th times, they're not even putting the dots in there now. They didn't before either. I did, okay. Square root of 2x squared y, the square root of 2x squared y, all those under the same house, okay, times the square root of 6xy squared. All right. Now you tell me, you want to simplify first and then multiply, or multiply first and then simplify? Second? I can't hear. This one right here? Yeah, 2x squared y. This is 3x to the 4th, 2x squared y, 6xy squared. Okay, I heard several things going on. What was those? Multiply first and then simplify. Okay. They didn't like what I did last time, did they? Okay. So that's going to be all under one big radical here. Let's multiply our numbers first. 6 times, that's 36. I think y'all are wise to do it this way this time. And then you have x to the 4th times, and then times, what do you say it comes out to? X to the 7th. Perfect. And then y cubed. Okay. Now, you know my next question. See any perfect squares lingering in there? What? Yes. And now look, you don't have to write the square root of 36 if you see it. You can go on and pull the 6 out. Okay? What else? More than that. X cubed, because you can pull a 6 out of 7. Now, when they're exponents, you really are subtracting. It's only the other things you have to be multiplied. And this would be, okay, you can pull out a y squared, and the square root of that is y. Okay, this is the disadvantage of doing it this way. You tend to either not take enough square roots or take too many or something like that. What's left on the inside? X times y. Okay. Now, I would do it this way because I'm used to it. I'm not suggesting you do. If you like it the way we were doing it, do it the way we were doing it. Square root of 36, 6. Square root of x to the 7th is not a perfect square, but if you factor out one x, then you have square root of x to the 6th times the other x. Leave that one out there. And this would be square root of y squared times y. Okay? Square root of x to the 6th would be x to the 3rd. Square root of y squared would be y. I would say write in as many steps as you need so you can keep it straight in your head and not make some dumb mistake. Okay? There's no reason to rush if it's going to lead you to an error. Okay? Take your time. Do it. Do all the steps you need. Anyone want to see those steps put back in? I'll be glad to do them. Okay, let's do them. Okay? If I were doing this from a teaching mode, I would say 36 is a perfect square, so let's factor that out. Okay? And then x to the 7th would be the square root of x to the 6th times x. Right? Yay or nay? Okay? And same thing with y cubed, it'd be the square root of y squared times y. Okay? Square root of 36 is 6. Square root of x squared is x cubed times the square root of x times square root of y squared, y outside the radical, and then you have another y inside the radical. Then combines the things that are on the outside, 6x cubed y, and then combine what's left over, the square root of x, y. Okay? Make more sense? Okay. Please don't skip steps. I heard over the weekend an old, I don't even remember what kind of wine commercial it was, but they were talking about Orson Welles, and he used to do the wine commercial, and y'all wouldn't remember any of this because you're too young, and he said, he had this really serious voice, we never produce a wine before it's time. Well, don't produce a math problem before it's time. Don't skip steps before you're ready to skip steps. Write them all in there until you say, oh, I know this. I remember last week we were doing for x to the 7th, x times x times x times x times x times x, 7 x's out there, and then we paired them up. And then I think it was Sierra said, wait, we could just do 6 and do 1. Okay? Yes. As soon as we saw that, then we could start doing that. So we don't produce a wine before it's time. Okay? We don't produce a product before we understand every step in the product. Take your time. Take your time. All right, let's see if the book got it. Oh, yes, they did. Okay, 6x cubed y times the square root of xy. Okay, there is a check your understanding there. Please do that as soon as you can outside class. Okay, now you can even do it inside class. I don't care. Now we have already done the top of this, and what we haven't done is what's under that rectangle. So okay, can I clear this? Everybody finish writing? Okay. Let's do the little multiplication, the little example thing they have there. Okay, we did those two. The square root of 2x times x plus the square root of 2x. All right. Sort of stepped up a notch here, haven't we? Doing something we quite hadn't described before. Let's see. What in the world would you do with this? What does it mean to have this outside this parentheses? Yes, we distribute this inside on both terms. Let's see what happens. Okay? When you multiply those two, what do you get? X on the square root of 2x. Nothing much has changed there. Plus, in fact, I don't even know why they have you doing this, but let's do it. This times that would just be 2x. Perfect. Okay? And guess what? There's nothing else you can do. Okay? You can't really Well, yes, maybe so. We can factor out an x, and that would give you the square root of 2x plus 2. And you know what? Yeah. Okay. It does seem wrong, but they didn't change that. They didn't combine that. They left it in this form here. Y'all okay with that? Okay, what you're doing is distributing this. This is outside the radical times what's inside the radical, right? Then plus, and someone said square root of 2x times square root of 2x, just like up here, is 2x, right? Okay? Now, what I did, because I thought they were going to take it one more step, both of these have an x in them. You can factor that out and leave square root of 2x plus 2. They didn't do that. So, yeah. It's perfectly okay. And this is where it's really confusing, whether this is final form or that's final form. They are okay with that. Okay? It never hurts to take it an extra step, as long as that step is correct. Okay? If you've got a right answer, you're going to get credit for it. In fact, one of the ones that y'all did on the test, I've got to go back. I said I was finished grading, but somewhere toward the last half of my grading, I thought, wait a minute. That is a right answer. It's not the answer they're looking for, but it is a right answer. So I started marking those right. I've got to go back and make sure I didn't mark any of those wrong before. If not, you might have a little bit better grade. But that's something I'm going to try to take care of before we meet on Wednesday. But if I find an answer that's right, even though it's not the form they want it in, usually I'll give you credit for it. Now, if they say simplify and you haven't simplified, I'll probably take off a point. But if they just say, what is this answer? And you give me a right answer, but it may not be the same one they have in the key, you get credit for it. WebAssign doesn't do that. By the way, if you've ever used WebAssign, they're looking for one and only one answer. If you had written this as the answer and they were looking for that, and you have no way of knowing what they're looking for, they say, nope, wrong, and it wouldn't be wrong, it's just not the answer they were looking for. I'll get off that soapbox a little bit for now. Okay. Any questions? All right. And again, they left it in the form above the line there. Okay? Now, they come up with a focus next. And this is it. Okay? I want to make sure it was. So what would you do with this one? Distribute. And what does that first distribution give you? Take as many steps as you need. Help me, help me. When you multiply those two, what do you get? The square root of? What do you say? Or did you factor something out? Huh? No. You said 9? What else?
9.
A squared? B. Got it. Then we got a plus. And then distribute these two. And what does that give you? The square root of? (27) A B squared. Perfect. Okay, all that's under the house. How about that first one now? What can we do with it? Factor out an A and a 3. You see, the square root of 9 is 3. Okay, what does that leave you with? B plus, what do you have here? Second, square root of 9, I agree, times square root of 3. Anything else? Okay, you have a B that you're going to pull on the outside, so I'll pull that out here, and you still have a square root of A to go, right? Okay? So, what's the square root of, that's a B there, not a 6. So this is a 3A root B plus the square root of 9. So that's 3b. And then what do you have under the radical left? 3a. Perfect. Perfect, perfect, perfect. Now, if I was going to do what I did before, I would factor out a 3. Okay, that would be okay, because there's a 3 here, there's a 3 there. That would be 3 times ab plus b root 3a. But they don't do that. They leave the 3's in there. I don't know why, but it's okay. Does everybody see that? We did skip a few steps there, so don't let it throw you. Someone saw immediately that's a 3. Square root of 9 is 3. Pull it outside the radical, okay? And the square root of a squared is 8. Pull that outside. So you have a 3a on the outside, and that's only left you with square root of b on the inside. Okay, like that. Now, also saw there's a 9 hiding in there, and that left you a square root of 3. Square root of that, square root of 3. And then someone saw there's a b there, so we pulled out the b. You could have left it as a square root of b squared and then pulled it out. It doesn't matter. But you're left with a square root of a in there. So this is so simply 3a root b. This is 3b root 3a. Make sense? Yay or nay? Okay, any questions? If you have, ask them, please. Okay, let's see if we can find another one. There's the check your understanding too. We could do that one if you don't want to do it later. Okay, so let's do that one. Let me clear that, and we'll do the check your understanding too. CYU2. Okay, on page 9, module 13, page 9. Okay. The square root of 5x times the square root of 5x. I have to look at these real carefully to make sure that x is under the radical. Okay. Minus the square root of 25y. And that y is also under the radical. Okay. Second? Oh, that's a 25, you mean under, let me see where I'm talking about. Yeah, a 25y there. Is that what you were asking? Okay, yeah. All right. What do you do first? Distribute. What is root 5a? Root 5x times root 5x. 5x. A radical times itself is whatever is under the radical. It's that radical squared, and the square undoes the square root, right? Okay? If you need to do the extra step, go on and do it, okay? We'll erase that. Well, I could have made it a little easier. We could have said the square root of 5 times 5 is 25. X times x is x squared. And then you're going to pull out your perfect squares. Huh? Okay, yeah. That's perfectly fine. Minus. Now let's distribute the other way. And what does that give you? $125 xy. Okay. Perfectly good way to do it. What's the square root of 25? Say 5x. You got it. Those come out completely. Your radical disappears because they're both perfect squares. Minus. Now what do you see in here? Any perfect squares in 125? Second? Well, there's only one I can think of. Yeah, 25 is a perfect square. Now that leaves you with the square root of 5xy. No perfect squares left there, so this will be 5x minus 5 times the square root of 5xy. That's it. Again, if you wanted to, you could factor out a 5 and leave you with the x minus root 5xy. But they're not doing that, so you don't need to. Does that make sense? All right. All right. Now, who was the chef that used to step it up another notch? Y'all don't know that either. It was one of the New Orleans chefs that had a TV thing. He was real good on TV. Step it up a notch. I can't remember his name, but yeah. So we're going to step it up another notch. We like our notches, don't we? Huh? Yeah, I don't remember. Probably wouldn't recognize it. Who is it? Okay, could have been. Okay. All right. What's that? Okay. Okay. Everybody got this one? Okay. Move on. Okay. So here's stepping up yet another notch. And that is, multiply this. Root 2 minus 3x times root 2 plus x. What in the world can we do with something like this? Second? Okay, it's already kind of factored. Foil it! Yes, curse is foiled again. Okay? So let's do the first one. And that's 2. Perfect. Then we do the outers, yeah. And that would be x times root 2. And that's a plus. So plus x root 2. Good. Then we do the inners. And that's minus 3x root 2. And then we do the last. What's that? Minus 3x squared. Perfect. Now what do we do? Combine like terms. There's no other single number, so we'll just write down the 2 there. But here we have 2 terms with root 2's in them. And what do those add to be, or subtract to be, or whatever? Negative 2x root 2. Perfect. And then minus 3x squared. Look at that. Y'all did it so well. Now, we're kind of used to putting the variable after the number, right? All before this, we've always done that. I don't like putting it after a radical because then I might get confused and think the x is under the radical, which is not. It's outside the radical. So I like to put everything that's outside the radical in first and then the radical. The book may do it differently, but that's the way I like to write it. That way I avoid my own messy handwriting. You know, I don't let that cause me to error, you know. Let's see how the book did it, if I can find it. Look at that. They did it the same way I did. Good for them. Okay. It's usually a pretty safe thing to do is put the radicals at the end so you don't confuse and think there's something else under it. Okay? Make sense? Okay. Does the problem make sense? Not how we wrote it. Does you understand what we did there? No? Where's the missing link? Okay, well, no. Which step lost you?
I can't tell you.
Huh?
I don't know right now.
Okay. Well, do you see this is a product of 2 basically binomials, so foiling is a great thing to do here, right?
Yes.
Multiply. So you understand the foiling part. Okay, the root 2 times root 2 came out being a perfect 2. You could have written down root 2 times root 2 and then root 2 squared, whatever. But if you saw that, fine. Then you do the order doesn't matter. I just did it because that's how you spell foil.
Okay.
Yeah, got it?
Yep.
Got it. Okay, good deal. And we get a smiley face if we do it that way. So that's an extra bonus, right? Okay. Never mind. Okay. Say again? Oh, okay. So let's see if we get this next focus here. Let's see what they do. Oh, okay, this is the last one we did. We're already through with. Did we do all that? Yeah, I think we did. Yeah. I know I did it, but did I show their work? I did, okay. I thought I had, but okay, in case I didn't. Okay. So let's see if the next focus. No, they don't do the next focus. Shame on them. So we'll go back and redo all that. Okay. Here's the next focus. How are we doing on time? We said that. Okay. Here we have a 2 root x minus root y times a 5 root x minus 2 root y. All right, and we're asked to multiply those expressions. And they tell you now, use the FOIL method, okay, which is an extended form of distributive, but yeah, I like it better. It's just plain FOIL. What would you do first? The what? Wait a minute. Is that what you said? Okay. Okay. What does the ELF in FOIL stand for? First terms. And your first terms are 2 root x times 5 root x. And what does that give you? Say again? 10x. Perfect. 2 times 5 is 10. Root x times root x is x. Okay? Then we do the what? Outer. And that would be negative 4 root xy. You can multiply those two together. Then we do the innards, and that's a minus 5 root xy. Yeah, you can multiply those two together. And then finally we have the last, which is plus 2, and then root y times root y is y. You got it. Why not? Okay? And what? Combine like terms. The 10x doesn't have a like term, so just write it down. And what does this give you? Negative 9 root xy plus 2y. Done. That's it. Nothing else you can do. Right? Any questions on that? Take it one step at a time. How do you eat that 5,000-pound elephant? One bite at a time. Okay. Take it one bite at a time. Or bits if you need to. That's computer judge. Never mind. Okay. Now they didn't show this on the slides, so let's see. 10x minus 9 root xy plus 2y. Good for them. They got it right. Any questions? Ask if you have them, please. Sure. We can do the check your understanding 3 if you want to. You want to? All right. All right, to erase this one, any more questions for our eraser? Go. Please ask if you got them. Okay, check your understanding 3. This is top of Module 13, page 10. Okay, it's a parentheses, 3 root x minus root y times, whoop, too many parentheses there. Where did that come from? Okay. 5 root x minus 2 root y. Okay. Again, product of 2 binomials. Curses foiled again. So let's go for it. And what do your first give you? 15x, because root x times root x is x, right? Then minus 6 root xy, okay? multiply the things outside, and what's inside, multiply those, but keep them inside. And you have another minus 5 root xy, perfect. And then the last is plus 2, and root y times root y is just y. Why not? Okay. Then you have a 15x. That's the only term like that one. And these give you minus 11 root xy plus 2y. Perfect. You see how that works? One step at a time. Foiling, multiply, 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 multiply. Combine like terms if you can. Sometimes you can't. This one you could. Simplify what you can. There it's done, I think. Let's see.
I have a question.
Yeah.
So if I'm multiplying the symbol, if we're multiplying the symbol will go away at the end when we get the answer.
Okay. Sometimes yes and sometimes no. If it's the same thing under here, and it's a radical x times radical x, that becomes radical x squared, which is x. Okay? When you're multiplying this one and that one, radical x times radical y just becomes radical xy. No square under there. They're just multiplied. So the radical doesn't go away there. It does here because it's the same thing under there. Square root of x times x is x squared. Square root of x squared is just x. Square root of xy, though, is just square root of xy. You can't pull out. You can't lose the radical there. You can here because they're both root y's.
Okay.
Root y times root y is root y squared, which is y. Okay? Anything multiplied by itself is itself squared. So a root y times a root y is root y squared. And square root of y is root y squared is y. Square root undoes the square undoes the square root. All right. So that was check your understanding 3, and they got 15x minus 11 root xy plus 2y. Good for them. All right. Now, we go to a new concept. It's not a new concept. It's an old concept, but we're going to give it a new name, sort of. Okay? And that's this. Remember when we were doing things like multiplying expressions like this, what did we get? A plus b times a minus b. What happened? You get what? Yeah, a squared minus b squared, right? You can follow it and see. A times a is a squared. A times minus b is minus ab plus ab is 0, okay? And then minus b squared. So you get the difference of their squares. Remember that? That enabled us to to factor the difference of two perfect squares, a plus b times a minus b, okay? Now, we didn't call them this back then, but the name for any time you have two expressions starting the same, then adding the opposites, okay? Those, the sum and the difference of two terms are called conjugates of each other. They're similar but different, okay? They're conjugates of each other. Same first term, opposite second term. Okay. Now, as I just said, when you multiply these together, a times a is a squared. A times minus b is minus ab plus ab. That always adds to 0. Then minus b squared. Okay. What if you do that with radical numbers? Okay. Then it would be the first. 2 times 2 is 4, right? Minus root 7 times root 7 would be minus 7. 4 minus 7, minus 3. Now, even if you don't buy that, you follow it like we just did. 4 minus 2 root 7 plus 2 root 7, that adds to 0. Minus 7. 4 minus 7 is negative 3. So guess what? If you have a number that's an irrational number, a binomial that's an irrational number, all you have to do multiplied by its conjugate, you're going to get a rational number, -3. Okay? There's going to be an advantage of doing that just a little bit later. Okay? Because what are we doing now? Multiplying radical expressions. When we go to the division of radical expressions, please give me some help with that. And we'll see why in just a few minutes, I think. If not, it'll be next time. Because we are running a little short. Okay? So the product of conjugates is the difference of two squares. That's fine when they're regular old numbers or letters or something, but when they're radicals, difference of their squares, the square of a radical is a rational number, okay? And then that would produce the difference of rational numbers. Okay. All right? Okay. Whoa, goodness gracious. End of the slide set? We didn't even get to do examples or focuses or anything else. We did do the first two of product of conjugates. Let's do the third one there. Okay? That's this one. Do we have time? No! Oh, my word. Okay. We'll start there next time. Okay. Now, when we finish 13.3, which will be next time, knock on wood, I'll try to have a quiz ready for you, okay, for Module 13. Your quiz for that, so then you can move on and get your, will be, okay. Okay.
But I need to go let my tutor know that I'm not here.
Okay. All right. Now, I have another class in this room. We'll have to find another room for you.
Okay.
Okay.